Okay, so I'm starting here. Okay, so you're going down to the intersect again. So hit enter, and now I want to go on the other side. So I want the left bound of that intersection. So to the left of it is going to be about 0.8 on the x-axis. So I'm still moving to the right. Okay, that's now to the left of the intersection. Hit enter. And then go to the right of the intersection and hit enter. And they automatically told me without having to hit it again, that intersection is at 1,6. So now I know I have two intersections. One's where x is -1, that's the lower one, and the other where x is +1. So now that affirmed what I thought I saw. Okay, so now we know which one's on top, and we know the endpoints. So we have everything that we need. Okay, and then we'll take, anybody need me to go back on anything on that graph? We okay with left bound, right bound for the intersection to find the endpoints? The picture showed us which one's on top. I can match up my colors. I see it's line minus parabola. Okay, is everyone okay with that?
Yeah, kind of.
Okay. Okay, so let me get out of here. So we'll take a teacher timeout and
Oh no.
yes,
No way, this is a gingerbread house.
Wow,
and
that's
they
beautiful.
they electrified it. They put
How did they
electricity.
do that? Is
I
that
don't know.
icing?
Yes,
Or
it's
what is
icing. Now, you know what? I said, oh, Jack, I can't believe you even did that. The koi fish.
Yeah.
How'd you do that? I'm thinking that they're just candy. Oh, no, no, no. Racine found a mold for it. It's white chocolate, which she then decorated with orange.
Oh
Wow.
Lord.
So
You
anyway,
gotta be kidding me.
I know, isn't it amazing? So
That's
they
beautiful.
went to Japan. So this is a temple from
I was gonna
Japan.
say that's what it looks like.
Yep.
Yeah.
Yeah. So anyway, we don't compete with Jack and Racine. We say, oh, with
No,
you.
no.
It's
There's no
unbelievable.
competition with this one.
I know there's nothing. So I'm going to see this next weekend, but they have two levels of lighting. So
Oh
it's just
wow.
unbelievable. And look how beautiful the pattern is.
That's
Right.
what I was saying. How did it stay?
I
The
know. Oh, and
icing.
then he has the windows too. The windows are a special sugar that they make.
Wow.
Yeah, they both have full-time jobs too, I might add.
What's the bridge made out of?
That's the thing I was looking at.
I think it's gingerbread cookie shaped that way. So I think they take it out before it's totally done and they shape it like a bridge.
Oh,
But anyway,
wow.
it's amazing. But so then keeping with the theme, wait until you see Halloween. Because
Oh Lord.
they always do gingerbread houses. And let me see if I can get, clearly we have a lot of family information here. My grandchildren. Let's see. So it has to be a little bit before here. So what date is this? Yeah, this is this is Scotland over Thanksgiving. So we need to go for Halloween. That's my other granddaughter. That's an anniversary. I will eventually get to where I want to get to. Okay, that's November. So we are getting there. Let me see. That's Halloween costumes. They didn't dress in costume, but okay. This is the Halloween carvings.
Oh wow. They carved that?
Yes,
Wow.
yes.
So
So
these are pumpkins?
yes, they're pumpkins.
No
That's
way.
incredible.
And he also put a lighting fixture in there. So this is on the right is the house that they live in DC.
Okay.
And this, I didn't know who that woman was. It is this woman. She's a
She's
singer,
a singer. Yeah.
Chappelle.
Yeah.
I don't know
Chapel
Chappelle, but I
Roan.
said, Racine, you made her look
Mm-hmm.
prettier than she looked in the picture you sent me. But yeah, isn't that amazing?
That's really cool.
Wow.
Last year, Racine did Taylor Swift on her album cover. fairly
Hard.
amazing. But, so they are talented
Yeah.
people.
This some artwork. This is like God gift.
I know, they take it to a new level,
This is another level of art.
but it's just
A lot of math
amazing.
involves for
A lot of
sure.
math, well, they're both, as I said, they're both engineers, and they have the X-Acto knives. But yeah, I think he put the glass, yeah, he put that sugar glass in here too.
Yeah.
He did a 3D printing of his house also, because he has a 3D printing machine, so
Mhm.
it's hysterical. But they are something. So anyway, that's my little aside. I still
That's
like them.
fun.
So anyway,
Yeah.
that's what they're up to up in DC, what my kids do in their spare time. Okay, so let's get back to this. Let me go back into my iPad. And I need to hit the share button. Hold on. Share. There we go. Okay, so same rule with this one. What you want to do is simplify this. So when you distribute nicely, here, here, and here, and you combine like terms, you get this. So again, you can make
Okay.
the calculator do this by saying y1 minus y2, and then turn off y1 and y2, and you'll see this shape. So what does that shape look like? You may wonder. So this is, let's see, this is negative x squared plus 1. So you're at 1 this way, but because it is negative, you are going down. That's what that shape looks like. And this is your -1, and this is your 1. So if I had subtracted those two functions, this is what I would have seen, and that's what I would have shaded in. So when I do the integration, I get x minus x to the 3 over 3, and I'm going to integrate it from 1 to -1. So your answer should be 1 1/3. Let's just make sure. If I plug in a 1, I have 1 minus, and that's just going to be 1/3. That's the first term. And then minus, so look how carefully you want to do this. That's going to be a -1. This is going to be a negative of a -1. This is going to be a positive 1/3.
Good.
So we get 1 minus 1/3 plus 1
Plus
minus
plus
1/3.
yeah, minus 1/3, yeah.
Right? Minus 2/3, which is 1 1/3. So we're okay. So that's what you're doing when they say find the area bounded. So bounded is like a mousetrap.
So
Okay.
then can you find that on the calculator too, like we did?
Yes, so let's do
for-
that. So I have it still in my graphing calculator on my phone. So let me get that open, and then I'll share screen, and we'll see if we can do the same thing. So let me clear that. Okay. So then let me stop sharing. Okay, so what I'm going to do in my next step, I'm going to come down here, and I'm going to say, I want line minus parabola. So I'm going to go to VARs. I'm going to go to YVARs. I'm going to go function. I want Y1 minus VARs, YVARs, function, Y2. And then what I want to do is I want to come up here, and I want to turn off my equal sign so that it doesn't graph that on top of it. So that one's off. I'm going to go up. That one's off. Okay, so that's good. Let me get off of that. Okay, let me go to graph. So there it is. That's just what I had graphed on my iPad. So that's the shape I want. Now I can say, let's do the math. So if I say second calc and I want the integration, and I want to run it from -1, enter, and then enter again, all the way up to 1, enter, and enter again, and it's 1.33, and they shaded it in for me, and that's equivalent to 1 1/3. So you can get it this way too.
I have a question.
Uh-huh.
I'm struggling to understand visually what happens when you do that because, like, obviously the curve that they're showing now is not what the intersection looks like. So what is this representing?
So this is the subtraction of the two curves.
Right.
When
But so
you
why does it
subtract that,
look like a completely different curve?
think of it kind of on its side coming down to the x-axis.
Oh, okay.
That's
Okay.
kind of what's happening, because you see how the connections are here and here?
Mm-hmm.
So envision them here and here.
Gotcha. Okay.
Then it's going to look closer to that. Josie, are you good? Does this make sense?
Yeah, it's a lot.
Okay, so let's just go back. If you want to put an integral on your graphing calculator, but not graph it, you would go into math instead. You would go to math, and then you would come down here to function integration. And then when you do this, once you look at the car ad,
Okay.
hold on, okay, close. Then you have this to plug the things in. Okay, so remember there's two ways to do it. But in our scenario here, so what you could do is, let's say once you figure it out by hand, if you don't want to see it graphed and the whole shaded in, once you have your new integrand that you got from the subtraction, and you've got your endpoints, you can put it in here and solve it. So let's make sure that that works. So let's just say I'm going to run this particular function from -1 all the way up to 1. And the function that I got for my final integrand was 1 minus x squared. And that's it. And then I'm going to move that out, and I'm going to say enter. So what happened? Okay, let me clear this screen. Maybe they have limited pixels on this. Okay, so let me go back into math, and let me come down. And you may have to clean all your screens for the phone. Okay, so I'm going to say, because I think it got confused as to what it wanted me to do, or what I was asking it to do. So put in your 1 minus x squared and come out of there and hit enter, and it just gives you the nice clean answer. So you've got to have your previous screen cleared. Otherwise, it will get confused. But see, that's still 1 1/3 without all the hoopla. So
Okay.
you couldn't do this until you knew which curve was on top and what the endpoints were. And then you're free to use just this and get that answer. Okay, so I think those are the two main topics. So now I said, let's do a little bit of practice. And I did practice of both types. So this is find the area of the region between two curves. Now they're not telling you what's on top. So that means you've got to graph this. So if I go back into my graph, so again, clear all your windows and clear all of these out, because I think the pixels are limited in what they can work with. Okay, so I don't know what's on top. I do know the endpoints though. So I want to make sure I can see my x's at least from -2 to 2. So I'm going to plug in my parabola, which is the one that has the square of 2. I'm going to plug in my line, which is just y equals 8. Now I'm going to peek at my window, and I'm not sure. I think I'm going to run this from my Y min, the classic is from -10 to 10. So maybe I'll do that. And then I can probably do a narrower window for the X's, which are higher up, because I need to just have it from -2 to 2. So I'm going to run it from -4. So I have enough wide enough to be able to see it, to 4. Okay, so now I'm going to hit graph. Okay, that's perfect, because I can see what I need. And do you see which one's on top? It's the horizontal line. Is everyone clear on that?
Yes.
So that you don't have to find the intersections because they told you what to run it between. So they want to run it between -2 and 2, which happens to be the intersection. But remember, because this is the area between two curves and not bounded, it didn't have to be the intersection. It just happens to be. So when you want to do this integration, you're going to do the integral symbol and you're going to run it from -2 to 2. And then everywhere in that area is going to be line minus parabola. So it's 8 minus 2x squared and then dx. So you're going to do the integration and use the fundamental theory of calculus, and then we're going to check it with the phone. So when I do the integration, what are you getting? So 8 becomes what? Just 8x, right?
Yeah. Mhm.
And then minus 2x squared becomes x cubed.
That's
Over
cute.
3.
And then it's
Over
2/3,
3.
right? 2/3 x cubed.
Two-thirds.
And then I'm going to put a vertical line, and on the top is going to be 2, and on the bottom is going to be -2. So then I'm going to plug in my 2. So I have 8 times 2 minus 2/3 of 8, right? Because 2 cubed is 8. And then I'm going to put that in a bracket, those two terms, and then minus another bracket's coming, plug in a -2, that makes it -16. And -2 cubed is a -8. So that's going to be positive 16/3, whereas the other one was -16/3. So let's see what happens. I'm just going to clean this up when we finish that. So now you can take away your parens as you distribute. So I have 16 minus 16/3 plus 16 minus 16/3. So that gives me 16 plus 16, that's 32 minus 32/3. So that's what, 96/3 minus 32/3, which is 64/3. Does that make sense? So let me just see if I did that correctly.
Are you able to show us? I'm sorry, I know you have to switch back and forth.
Yep. Yeah, let me just see what I just did. What did I just do? Okay, so let me stop sharing here and go to my iPad. Okay, so I said find the area of the region between the two curves. And I got that that antiderivative is 8x minus 2/3 x cubed. So then I plugged in a 2 and I got 2 times 8, which is 16. And then 2/3 of 8, right? So that's 16/3. And then I got something very similar on the other side with opposite signs. So then I added the 16s together, that gave me 32. And I subtracted 2 of the 16 thirds, which gives me 32 thirds. Then I multiplied 32 times 3/3 and got 96 thirds minus the 32 thirds, and I got 64 thirds. So that is going to be 21, whoops, and a third. So this is 21 and a third. So try it on your calculator by saying second calc. So let's see what I have to do. I have to do the subtraction first, don't I? So I could just put in 8 minus 2x squared, or let the calculator do it for me. So I'm gonna have the calculator do it for me. So let me set this up. You set yours up. I'm gonna do a subtraction. And this time I want line minus parabola. So I'm gonna do y2 minus y1, because that's the order I put it in. So I'm gonna say vars, y vars. This time it's gonna be y2 minus vars, y vars. Y1, turn off the equal signs of the other equations. And then I'm going to graph that. Okay, let me clear this first. Clear this, and then say graph. Yeah, that looks right. Okay, so that's my graph. And then I'm going to run that from -2 to 2. So now I want to say second calc, and I want to do the integration. And I'll set all of this up. From the left bound is -2, enter, enter. The right bound is 2, enter, enter. And it's getting me 21 and a third. So were you able to do it both ways? Toyosi, how about you?
Yes. So what did we get the final answer?
21 and a third, or 21.3 bar notation?
Small. It's like I'm saying 10.66, 32.00.
Do you want to see my calculator?
Sure.
Okay, so let me get out of this. Okay, so in my graph, this is what I did. So I knew I
Yeah,
had
that was
8 minus 2x squared. So that's going to be y2 minus y1.
oh, I didn't close up my equals.
Okay, yeah. So get rid of this shaded in equal signs for the first two.
And then I'll come back and then I'll graph.
Yes. And I go to graph, and I already ran it with lower bound -2. I hit enter twice. Right bound.
Yeah, so now I get the right answer now.
Okay,
Yeah.
perfect. Okay, so I have one more like this one. And Angela, do you match up on the calculator too?
Yeah.
Okay, good. Okay, so let's look at the second one. Okay, so this one says, again, I have two curves. All I know is that it's gonna run from -1 to 1. I don't know what's on top. So I'm gonna have to graph it to figure it out. So see if you can clear all of your screens. And put those two in and figure out what's on top. I'm gonna put the y squared plus 1 in the y1. Excuse me, x squared plus 1. And then I'm gonna put the negative x squared minus 1 in the other. And then I have to look at both of them. Oh, and I know I have to be able to see from -1 to 1. I should be able to see it with this. Okay, so I've got two graphs. And it looks to me like the first one is my blue one. That's the x squared. That's on top. Are you seeing that on top for yours too?
I'm still putting the equation in. So we had the x squared plus 1 and the x minus x squared minus 1. Okay.
Correct. And you don't have to
And then-
change your window. The window is pretty good.
And just, yeah, graph. Yeah, the blue one is on top and the red one is under.
Good. So that means when I write it out, I'm going to write the top one, which is the blue, which is the x squared plus 1. And then minus, now remember, you've got to put this in parentheses because you're going to be distributing the negative. So that's what I get. So now let me just make this stuff a little bit smaller, maybe. Okay, so now I'm going to do this one. And I'm gonna simplify this integrand because it's a little bit too much. So let me say that I'm going to say same idea, -1, 1, and now it's going to be what? X squared plus 1, and then a minus, so that's plus x squared, and another minus, so it's plus 1, and then all that is in front of dx. And then I'm going to end up integrating
2x
at
squared.
2x squared plus 2, right?
Yeah.
So then that's going to equal 2x cubed over
Cubed
3 plus 2x. And I'm going to
Mhm.
run that from 1 to -1. So that means that's going to be 2/3 plus 2 minus, that's going to stay negative. So that's a -2/3 minus 2. So that's going to be what? 2/3 plus 2 plus 2/3 plus 2. So that is 4 and 4/3, which is 5 and 1/3.
Hold on, quick one. We're putting, what are we doing right now? We're putting the numbers, right?
Yeah, we're doing the fundamental theory of calculus. So this is F1 minus F2.
Oh, okay, yeah, got you. Okay.
And excuse me, this is F-1. Okay, and so I'm getting 5 1/3. Angela, did you get 5 1/3?
I did. Should we leave it as a mixed number of fraction or put it in decimal form?
Well, this is a more exact answer because it's going to be 5.3 bar notation, right?
Mhm.
So you might as well leave it as 5 1/3.
Okay, so like on the home, I know it wasn't the same exact thing, but on the homework, where was it? It was saying to put your answer, like round it, round to the nearest hundredth as needed when we were doing definite integrals.
Okay, so then you would do 5.33.
Okay, so is it like when we do the areas with the curves, it's better to leave it as a fraction, or does it?
It just matters what, I guess what you're told to do.
Okay,
Like in
just
this
read the
case-
direction. Okay, I can do
Right,
that.
in this case, since it's silent to it, I just did the exact answer.
Okay.
Okay, so those are the two examples of bounded. So do you want to do that on the calculator too? Because you're gonna have to subtract those two equations, right? And then just run it from -1 to -1 to 1, because they do left bound, right bound. Do you feel that you can probably do this at this point?
You should.
So then why don't we go and do the bounded ones? So these are bounded. So bounded means they're not giving you endpoints and they're not telling you what's on top. So you've got to kind of give yourself a big enough picture that you're going to see where these things are going to intersect. So we're going to put in those two equations. One's a line and one's a parabola. And I think if you keep the current window, you're okay, as long as you clear everything out. And so I'm going to do x squared in the first one. And then I'm going to do x in the second one.
I think we need to reduce the thing. It's too close.
Right,
Can
it's
barely
too
see.
close. So that means it looks like all my action is between -1 and 2. So let's make that what I need on my x. And how about from 2 to 2 on the y, -2 to 2. So play around with the window. I'm going to go -1 to 2 for the x and -2 to 2 on the y. And let's see what that does for me. That's better. Can you see now that it's line minus parabola?
Are you on 3
Okay.
or 4 right now?
I'm on 3.
Okay.
So based on what I'm seeing here, I know it's the red one minus the blue one, and my blue one was the parabola. So that means
Yeah.
I'm gonna do line
So
minus
it's
parabola.
the endpoint is 0 and 1.
Well, that's what it is visually. Make sure you can check that to make sure that's exactly what it is, and that it's not like 0.95, you know what I mean? So if I were to say second calc, and I want now the intersection, and I'm just gonna get the left bound one, which I want it to be 0. So I'm gonna go to the left of 0 and say that's my left bound. Go to the right of 0, so that's my right bound. And yep, it's giving me 0, 0, which is what I want. And all that's important to me is the x value. Then I'm gonna do the same thing on the other side, second calc, and I'm gonna do my intersect, which is 5. And I'm going to do it a little bit to the left of 1. And then a little bit to the right of 1. And I have 1, 1, so I know I'm good. So I'm going to run it from 0 to 1. And now I have all the information I need. So now we're going to take the integration, which will be what? X squared minus x cubed over 3, running it from 1 to 0. That's easy enough. So that's going to be 1 minus 1/3.
Wait, does it have
Minus-
to be x squared over 2?
Oh, thank you. X squared over 2. So 1/2 minus 1/3 minus 0. So 1/2 is the same as 3/6. and 1/3 is the same as 2/6. So my answer should just be 1/6. Okay, so not bad. You have to do a little bit more work because you have to figure out where the endpoints are. But other than that, it's the same. So do you do any kind of support on the calculator for that? So the last one is also a bounded. So that means you've got to put those in your calculator, figure out what's on top. You've got a parabola that's downward facing, and you have a line. So remember, clear everything out. So don't forget that negative in front of the x squared. And I'm gonna leave the window the way it is, and I can't see what I need.
Yeah, me too.
So now go back in, and why don't you make it a 10 by 10, and then we'll make adjustments as we need to. So Y min is gonna be -10, Y max will be 10. And X min will be -10. This is called a standard window. And X max will be 10. And then let's see. Oh, that's much better. So that looks like it's going from 0 to 4, but you would check it just to make sure. So I know my endpoints. Let's just say that we checked it. So it's 0 to 4 is where the bounds are. And then this is parabola minus line, because that blue parabola is on top. So it's going to be -x² plus 6x minus 5, very carefully in parens, minus 2x minus 5 dx. So then do that math. And I'm getting -x² plus 4x, because the -5 and the +5 canceled. Is anybody else getting that?
Yeah, I got that.
Perfect. Okay, so then take the integration. And then we're going to do the fundamental theory of calculus from 4 to 0. The 0 will just be 0, so you only need to do the 4. So that's what, -64 thirds plus, that's also 64 halves. So I made them both over 6s. And 192. So I have 32 thirds, which is a little bit more than 8. Oh, excuse me, a little bit less than 8. No, a little bit more than 9. Let me just do that in my calculator. Yeah, 10.67. So that's 10.67, which is 10 2/3, my guess is.
Mm-hmm.
But we'll leave it as 0.67 just for right now. Okay, so was that good?
Mhm.
So you can do both the area
Yes.
between
See,
curves and the area bounded. And you can do it on the calculator and you can do it by hand.
So if we were to write the answer, what's the like proper form to write the answer? And like, do we need to put the integration symbol with the end points?
Yeah, so if you're gonna write your final answer, so it's gonna be, I'll write it out, the area between 0 and 4, and the final, well, the integration I did was negative x squared plus 4x dx. That equaled 10.67. And so that you can put in your calculator. The other work, when you do the fundamental theory of calculus, is just showing work. It's not necessarily the part of the solution, so to speak, part of that equation. So let me just get off of this and back into my iPad.
So you write the function before you do the integration.
Right.
That's what I was getting confused on.
Yeah, so that's what it would be. So this is my cleaned up integrand right here. I'm taking the integration with respect to dx. I have my endpoints and I have my answer. And then this piece right in here is all the work I did with the fundamental theory of calculus.
okay.
So this was what F4 right here. And because F0 would have been 0, I didn't even write it. Because it's really negative 64 over 3 plus 64 over 2 minus 0. And then I just got, I worked to get the same denominators so I can get an exact answer. And then I'm good. So when you're doing Riemann sums, the difference is when you write it in integral form, your equal sign is going to look like that because it's an approximation, right? So this is for Riemann sums. Okay, but once you actually do the integration, you're getting an exact answer. So that's it. You have the whole kettle of fish. So you've got derivatives, you've got integration, you've got the in-between world of Riemann sums.
On the rebound.
Yep, it's all good. So derivatives, remember, they were like slope of lines drawn to
Mhm.
curves. And integration is area under curves, so
Yes.
they relate to each other. And the calculator comes in handy for both. So I was gonna grade I'm gonna post these notes, so I'll post these notes and the video. And the video kind of didn't start till a little bit later, but I think I recapped enough that it should be okay, that you can cover both, plus my filled in notes will be everything.
Oh, okay.
So I'll have those two things up. I'll grade your problem set tonight. And then once I finish grading the problem set, I'll give you feedback on it and I'll post the test tonight.
Okay.
Okay, so I'll open it and then do it when you can. I'll check it probably like Thursday-ish. Sound good?
Yes, thank
Yeah.
you so much.
And I think there is a survey to do, so if you get, you should be getting an email of it, if you get that. Just
Mhm.
kind things.
Thank you.
So we should be all set. So what do you think overall about calculus?
It was fun.
Yeah, it is fun.
It is
It's
fun.
nice to get back into it because I forgot
Yeah.
everything.
I
Yeah,
haven't done this much math in a long time because I take early childhood, so it was just fun. All my other co-teachers was like, "Oh my God, you must be crazy." I was like, "All of you, none of you is, all of you are used. None of you could help me." They were like, "Oh no, what are
I
you
know
doing with calculus?"
this is
They're
slightly
like,
above,
"Sorry, we can't help you here."
yeah,
Yeah,
I
you know,
know,
Even
I
one
it's
of my
something.
parents that used to ask me about my classes, and I told her I was taking classes. She's like, "Huh? You take a calculus? Oh my God, Mr. Yossi." And then when I had the test, I printed the paper and I showed her. She's like, "Uh-oh, oh no."
Yeah,
Just
and you're
looking at
supposed to
all
have
those
done so
numbers,
great.
I could, I'm seeing triples. I'm like, yeah, I gotta solve all of this.
I know. So,
It's
so
like I
you,
don't have you at all.
yeah, no, it's something. It makes you really think, but it's kind of fun how it all kind of fits
It
together.
is.
I teach 5th and 6th grade math, and so my students know that I'm in grad school, and sometimes they're like, "Can you show us what you're doing?" And so when we were learning derivatives, I showed them how to just algebraically find the derivative,
Mhm.
and they were like, "Oh, let me try." And they were actually getting it. Now they didn't
Yes.
really understand why they were doing it, but I was like, "You're doing high school math," and that was pretty exciting for them.
Oh, yeah, no, that's very cool. Well, I just had to, one of my colleagues had back surgery and he teaches BC Calc, which is Calc 2
Mhm.
at the college level. And so anyway, I have had to cover for him. So we're doing this only with polar equations. So that means it's a whole, it's just a whole different thing. You've
Yeah,
got to put your calculator, let me just stop sharing this, this is going crazy. You have to put your calculator in radians for one, with all angles. And there are such cute little things that you can make little flowers with radian measurements, and then you have to figure out the area of these flowers, which is the same thing we're doing, the area between two curves. So it's interesting, but it's a whole
that is,
ballgame.
yeah.
You just kind of take this fundamental stuff and take it up even higher.
Yeah, that is really cool. And I always want, like, I teach middle school, so I'm not going to be doing this on the regular, and I don't want to lose it because I know I lost it after high school. So I don't know if you have
Yeah, me
suggestions
too.
on how to incorporate it into daily life. Not that I need to do this daily, but I just feel like it would be nice. You know, once our students graduate, sometimes I have old students ask for help in high
Yeah.
school math. So
Well, you know what's fun to do? Like if you even did like a Riemann sum type thing, which is just like a curve and then
that's
have
true.
little, they can do that. The
That is
little
very true.
areas of the rectangles. And
Mhm.
then you could be able to do it with integration and match up their answer.
That's true. That's a good point. I should do that. And I
Yeah.
have our school uses IXL. So like last night I was preparing for the test on IXL with my school account. And I was just searching up like finding definite or indefinite integrals. So that was good to use that.
Oh yeah, that's good. Well, and Khan Academy has a calculus course on it that
Okay.
you can take for free. That's up there. So there's a lot of neat stuff. Now I have the password to the AP College Board course. So that's kind of cool because they do videos on it too. But I do like Khan Academy they have a calculus class. They have an AP calculus, which is like Calc 1, which is what we're doing, only with trig as well in it. And they have a Calc 2 class, which is the next level, which is what I'm teaching right now. No, not to you guys, but to at Good Counsel.
Oh, okay.
But so there's all kinds of free stuff out there too, just to keep it going.
Yeah.
But it does kind of relate to other things that you wouldn't think it would. You know, just even in like preschool, if they're coloring under a bridge,
Oh yeah.
area.
Or when they're putting the magnet house together, and I'll be like, oh my God, that's like a curve they just made with this magnet house. And they're just building stuff. And I will be looking and I was like, oh Lord, I consider concave
Yes, yes,
because
yes, yes. You just
because
see things
they
a
have to
whole
use
different
the
way.
curved magnet house to fill up the space. And in my mind, when I was looking at it, it was actually, I think it was today. So one boy he said he was building a roller coaster. So he got to a point and I think there was like a curve. So he had to now take the curve magnetized to put inside. So when they put the cup inside, I was not looking. I was like, wait, that's the conch
Yep,
going on. And then he was looking at me like, but seriously, what are you saying? I said, don't worry, you can understand.
I know. Yeah, and just think about functions like roller coasters, increasing, increasing, increasing. Oh, I kind of
Yeah, yeah.
decreasing,
And
decreasing, decreasing.
there it is, putting it. And I was like, oh my God, what is going on in this place? My head was just was doing calculus.
Yeah, it is something.
All the
It is
shapes
something.
now.
Well, let me post
Triangle,
all this stuff.
rectangle, and circle anymore.
Yep, so it
I'm
can
seeing
drive you
different
crazy.
things.
But I'll post this stuff for you, and then if you have any problem with the test, just let me know. I have a little bit of a
Okay.
situation kind of playing in the background. My cousin is very ill, and he's in the last stages of hospice. So I'm kind of waiting to see what's going to happen. So if I don't get back to you right away, I'm gonna have my phone with me, but I need to go up to New York once I get the phone call. But hopefully it's going to be another couple of days, and I'll have all the stuff done. But that's what's going on. But he's a lot older than I am. He's 86, and
Oh, wow.
he's a pancreatic cancer survivor,
Wow.
which is
Wow.
really something. He had a
Yeah.
pancreatic cancer surgery at 79 and did great. But now it's kind of, the end of his life. But anyway, he's not in any pain and it's good, but it's kind of a lot to kind of wait for. It's like keep waiting for the phone to ring. But
Yeah.
because he has not eaten now in 2 days. So I know the time has come. So we're just kind of waiting. So anyway,
Yes, anytime. It's anytime. Because I used to take care of seniors. So I know I've been in that stage before that
yes.
even apple right in my hand. I would be like away in the offices. I was the one because the daughter too, she was a lecturer. She's a lecturer, so I was the one I was the one taking care of the mom. So I
Oh,
was the one in offices. I was like that one-on-one. So
yeah.
I was like personal care for them. So I was with her too. So when it happened, I just even it was my first one. After that one, the next one that happened, I wasn't more scared anymore. But the first one was a really shock for me
Yeah,
because
no,
I
it's
could just notice the breathing just went down. I was like, and I'll page the nurses because and then the nurse was like, oh, she's gone. I was like, huh? No, it can't be. She was just I could still feel her. Right now, I
I
just
know.
quickly
Well, how
page.
special that you were there with her because that's
Yeah, called
amazing.
the daughter and like, yeah, she was just running from class, like, but she was just happy at least one of us was there with her while
Yeah.
it happened. Yeah, so
A lot of times they do leave once the family members have left the room. It is
yeah.
interesting. But so we'll see. I didn't get many messages today, so we'll see what happens tomorrow. So I'm gonna try, that's why I'm gonna do everything tonight and get all this stuff squared away, and then I'll just be able to access my computer from wherever I am. So
Okay.
that's the plan. Well, thank you so
Okay.
much. I so enjoyed this class.
Thank you. So
Thank you
when
much.
should we expect our grades should be in?
Oh, once you take the test, I'll grade
Mm-hmm.
it that night. And then I'll
Oh, okay.
post it as soon as I can.
Okay. All
So
right.
everything should be
Okay.
done, like, if you take it by Thursday, it'll be up by Friday.
Okay. Okay.
Okay,
Yeah, I want to try and do it before Thursday because I'm trying to finish up all my others.
Yeah,
yeah,
I'm gonna try tomorrow.
once you posted it, since I'm letting you kind of have a range, just text me and tell me it's up, and then I'll go in.
Oh, okay.
But I don't get
Okay.
notified unless I go and constantly check.
Mhm.
So just text me when you posted it, and then I'll get to it right away.
Oh, okay. Okay. All right. All
Okay,
right.
well,
Thank
very
you
good.
so
Flexible.
much.
So enjoy the rest of your courses. I hope they're as fun as calculus.
I
Yes.
know, right? It's been fun.
I know. I've
Thank
taken
you.
like, what have I taken? I've taken algebraic functions and something else that was algebra and this. So I have a lot left that are less than calculus. So I'm hoping it's not too bad the rest of the way.
Yeah, I
Yeah,
think
no, it'll
mine is
be.
just all this one. Everything I have, and I think I have I have physics or something. Because I was trying to these are my prerequisite because they said I needed science, prerequisite, and English. I want English. So the rest I have was is science, and then my final 604, which was this is my final paper for graduation in May. So
Well, I think your science, your physics, usually they teach physics not calculus based, but I'll tell you,
mhm.
knowing calculus, oh my goodness, it makes things a lot easier in physics.
I
Because
know,
even if
right?
they're not
Because
teaching it that way, you can still understand it with calculus. And you can check answers a lot quicker because you have like, it's like knowing how to take derivatives when you're working on limits. If you already know that, you can check your work. So you should find
Yep.
limits, to go hand in hand with this very nicely.
Oh, okay. Thank you.
So very good. So I will see you again at some point. Hopefully our paths will cross. But just
I
reach out if there's
know.
a problem with the test or anything, and then and just text me when you have it up and I'll grade it.
Perfect.
Okay. All right. Thank
Thank
you.
you
Okay,
so
expecting
much.
great
Good
things.
night. Nice meeting you. Bye,
Thanks. Yes,
Angela.
nice meeting you guys.
Bye.
Good seeing you
Bye.
again, Angela. Bye-bye.
Thank you.
Bye.